Hello, and welcome to Field Lab Earth, the podcast that's all about past and present advances in the fields of agronomic, crop, soil, and environmental sciences. Today we'll be talking to Garland Pinnix about turfgrass colorants. What do turfgrass colorants do? What are some advantages of their use? How do you determine the right one for you? Answers to all these and more coming right up. I'm your host, Abby Morrison. Let's talk about science. Hi everybody, welcome to the show. Today we have the pleasure of talking to Garland Pinnix. He goes by Drew. Drew is a research technician and PhD candidate working under Dr. Grady Miller in the Department of Crop and Soil Sciences at North Carolina State University, where he received both his bachelor and master degrees in turfgrass science. He's originally from North Carolina and plans to complete his doctorate degree in 2019. Welcome to the show, Drew. How are you doing today?
I'm good. I appreciate you having me on.
Wonderful. We are so glad to have you. So today we're going to be talking about turfgrass colorants. Can you just give us some background information on what they are and what they're used for?
Sure. So the term colorant, that's kind of an overarching term that refers to a couple different products that we use in turfgrass management. Those being pigments, dyes, paint products. But in simple terms, a colorant is just anything that changes the color of the turf. And typically, turf colorants are used as an alternative to winter overseeding to give green color to warm season grasses during the winter months.
What are some of the benefits that colorants have over overseeding with those winter plants?
Well, there are a couple main benefits that stick out whenever you think of the use of turf colorants. The main one being is the transitioning from cool season grass back to a warm season grass in an overseeded situation can be very difficult for a manager of turf grass. It takes time, need the correct weather conditions, and when you don't overseed and you use something like a turf colorant, you get a much easier spring transition back to your warm season turf. So you don't have that competition between the warm and cool season turf. Another benefit is also cost, and that varies from year to year with the cost of seed prices. But with the overseeded turf, you have to pay for the seed, but once you get it established, you also have to pay for the season-long maintenance of that overseeded turf. So there you have labor costs, fertilizer costs, inputs, fungicides. So there is a cost benefit by using turf colorants.
Yeah, obviously the maintenance is a big cost, but I didn't think about the fact that using a colorant just also means you've got a pretty steady cost. You know, like it's probably not as variable from year to year, I would guess. And also just less work because you don't have to apply fungicide to paint.
Yeah, correct. And given the weather conditions from year to year, you may have to make an extra application here too, which will raise your cost of paint with your turf colorant. But it's nothing like, a steady cost for the season-long maintenance of a overseeded turf.
Yeah, or, if something happened that kills your overseeded plants, that's obviously going to be a lot harder to replace than paint.
Yeah, correct. Whenever your paint starts to go off color, all you have to do is simply go out and make a subsequent application to brighten up that color.
Sure. So in your paper, you were looking at really just cataloging some of the attributes of these different colorants. I believe you had, 27 that you looked at?
Correct.
Yeah, and so you were looking and comparing all of these, and there were a few different things that you were really taking note of. Can you tell me what those things that you were tracking were?
Yeah, so our main objective was to just monitor the color of these 27 products over time throughout the winter. So one of the color parameters that we were looking at was just the color of the turf after application of these turf colorants. Also, the colorant intensity, which that's kind of a new term that we use to evaluate these products, but typically how I explain that to people is kind of a coverage rating. So in typical turfgrass ratings, we often rate a turfgrass from 0 to 100% cover, and that's just literally how much of a given area a turfgrass covers. But when you look at a dormant leaf blade that's been treated with colorant, even though from 6 foot above the ground it looks like it's completely covered with paint, when you closely analyze that leaf, there's literally dots of colorant on the leaf blade. So it's not a true coverage rating. So we termed it intensity rating. And then lastly, we looked at hue angle. And we quantified hue angle by taking photos of a treated turf and using a software to quantify that hue angle.
Yeah, I know hue angle was kind of one that I had to come back to you and ask. So the way I kind of, that you explained it is that if you had like a stick in the middle of a ring and then you took the visible spectrum, so like, you know, red, orange, yellow kind of thing, and wrapped it around that ring, then the hue angle is like where on the ring that color is. Is that?
Yeah, exactly. That was actually a pretty good job.
Perfect.
Yeah, color is very difficult to quantify. Whenever we think of color, it is a 3D aspect that you're dealing with. And then when we talk about hue, saturation, and brightness, that is one way to describe a color. But for hue specifically, we are just talking about, okay, is it green? Is it red? Is it orange? So with these products, we were trying to quantify the hue angle and detect what color each product was after we applied it.
So what then is the difference between the color itself and the hue angle?
Okay, so hue is actually one part of defining something's color. In the color space, hue, saturation, brightness, hue is just one part. But hue is defining whether something is green, whether it's yellow, orange, red. So you have other terms that are additional parts of the entire color equation, but the hue angle part of the equation is telling you the general color, whether it, like I said, be blue, green, orange, or red.
Gotcha. Yeah, so you said other aspects that would combine to make color would be, for example, brightness or saturation. So brightness would be like in art school, you've got tints and shades, so it's the same base paint color, but then you add white or black to make it brighter or darker.
Exactly.
And then saturation is how much of the color is there. The way I would think about that is like if you have food coloring, and it's the difference between like water with 1 drop of blue versus 7 drops of blue. So it's like how much parts per million of color is there.
Yeah.
Does that make sense?
Yeah, that makes sense. You know, like we mentioned earlier, color is it sounds simple, but when you really start to break it all down, it can get very complex in trying to define something's true color.
Yeah, what a fun challenge for a researcher. So you were kind of looking at the color as all of those pieces combined. Intensity is kind of maybe closer to saturation, and then hue angle is just the actual tone of color itself. So once you had those pieces all set aside of how you were going to, what you were looking for, how did you go about figuring out what those different rates were? Can you tell me about your experimental design?
Yeah, so what we did was, well, first of all, we waited for the turf grass to go completely dormant. And then we went out and made a single application at a couple rates of all 27 products. And after that, we rated each plot for these different ratings, being the colorant, color, intensity, and hue angle, every 2 weeks throughout March. So we would go out in November, make the application, and then every 2 weeks we would make the ratings for each variable up until March when things started to green back up. And the colorant, color, and colorant intensity ratings were both visual ratings, the color rating being on a 1 to 9 scale, 1 being a brown, no colorant present, and 9 being a dark green color. And then intensity on a scale from a 0 to 100%. And then, as I mentioned earlier, their hue angle is on a scale of 0 to 360 degrees.
I have many questions off of just that. So first question is, how big are these little mini plots? Do you have all 27 on like a football field? Are they, the size of a car? How big are these?
The plots that I had, they were 6 by 3 foot plots, so they were 18 square foot plots. As you could imagine, with 27 different products replicated 4 times with 2 rates, that gets to be a pretty large area. So given one of our experimental blocks, we had to reduce the plot size so where we could fit all of our products on one experimental block.
Where are you doing this research? Presumably you're not on like the NCSU football field while you're doing this.
No, we were at our local research farm in Raleigh. We have a 35-acre research farm here about 5 minutes from our campus. So that allowed for where we, could control traffic on our plots throughout the winter season.
Good. And then in thinking about the color rating, are these designed as products? Are they designed for different kinds of fields? Like you think of a golf course and there's different shades of green all across the golf course. Are they specifically, this is a putting green one, this is a soccer field? Are they marketed that way, or are they just kind of like, this is a color for wherever you want to put it?
I would say all of that. Some companies do market their products as, matching a certain grass or turf. And then some don't specifically say, hey, we are trying to mimic a certain turf color here with this product. But yeah, definitely some products are formulated to match maybe a lighter green. Some are developed to be a darker green color. So yeah, there is a bunch of different colors that you will see after you apply these products.
Yeah, I like that, because I think I went into reading your article thinking of it as like a tournament style where it's like there can only be one, but that's really not the case. And that's what's cool about this research, is being able to really develop resources to help turfgrass managers really find what is best suited to their needs, regardless of, what those needs may be. So I like that a lot. And then my other question is, how, if these are all just visual ratings, how do you strip out just kind of the human perspective side of that as you are taking in this data? I mean, there's always that question of like, how do I know the red that I see is the red you see? Like, how do you actually go about rating these different things?
Exactly. And, getting back to like we mentioned earlier, everyone perceives color, in a different way. So in rating these, obviously in any research project, you try to maintain the same rater, or the person who's making the ratings, try to make that consistent throughout the project. So you have a consistent person viewing these. So for the colorant, color, and intensity ratings, I was going out there every 2 weeks. So we were trying to be as consistent as possible there, having the same person rate these plots. But then that's also why we were trying to use images and as an objective way to try to rate all of these different colors and trying to figure out the hue angle for each product.
Yeah, I'm curious, were you just going out on the day and being like, this is the number, or do you put in like, this is probably the number, and then take pictures and then go back and compare them across weeks and like kind of adjust things? How does that work?
No, there is no adjustment from week to week. Typically what I try to do, each rating day, every 2 weeks I would walk out and I say, okay, here's the entire study. It's got all of our different plots. I would go to the plot that, let's say colorant color, for example. I was getting ready to do a visual color rating. I would go to the plot that what I would think would be the worst rating, okay? And I would establish that rating for that plot. And then I would find the plot that would, in my opinion, have the best rating. And I would say, okay, hey, that's an 8. Worst plot was rated a 2, best plot was rated an 8. And then I would try to find some plots, in between those and kind of get a feel of, the different colors and what ratings each one should be. And then after I got a good feel for what we had that day, I would start from, plot 1 and then go through all of the individual plots.
How does technology help you make these decisions for the hue angle specifically? Obviously, as humans, we're probably not going to be able to tell the difference between 122 and 123 just at a stab. Do you use computers at all to go into Photoshop and be like, oh, this is the RGB code for it or whatever, which translates into that? Do you use that at all? Or is it just all, this is probably 120 to 125 kind of deal?
Yeah, see, that was our whole reasoning for using hue angle and quantifying the color for these, is so we would have a hard number that we could reference back to each product. But as I mentioned earlier, turf colorants painted on a 3D canvas that you have with a turf grass, it is nothing like, putting paint on a wall, which is, just a 2D surface, and you're able to apply an opaque layer of paint on that wall. When you're spraying a turf colorant on a 3D canvas, you do not coat the entire surface of a leaf blade. What you get instead is, like I was saying earlier, it's just individual specks across that leaf blade. So an actual very small percentage of that leaf blade actually has paint on it. So when you're using images and software to quantify hue angle, the majority of the color that you're seeing is the brown dormant turf grass. So that really confounds trying to get a hard hue angle value for that turf colorant. So that was the issue that we dealt with, trying to use hue angle as the sole variable to quantify the color for these products. That's why we also had our visual ratings as well.
Yeah, that's super fascinating. It's always refreshing when it's like, see, computers can't do everything. Like, go humans.
Yeah, no, like I said, we tried, and it works to a certain extent, but it doesn't. I guess it doesn't work quite as well as you'd hope, because like you said, you've got so much background noise there with a brown turf grass. You can't specifically pick out only the parts of the leaf blade that have paint on it and then try to quantify hue angle for that specific color.
Yeah, I used to do work with Photoshop at a previous job, and I remember trying to be like, I want to take this color out of this photo so I can use it on something else, and each pixel was so different that even though I could see, oh, I want that orange, actually trying to go in and find that orange was very hard. So I can sympathize with the dilemma here. So what a cool little crosshairs.
As a researcher, you're always looking tools and technology to get an objective rating of, whatever variable you're trying to quantify. And oftentimes, or at least in my experience with turf, I still believe that a human rating holds a lot of value still.
Yeah, for sure. Thank you for being one of those humans. We appreciate it.
Everyone who rates turfgrass has to deal with the same issues.
Hey everyone, I hope you're enjoying the show. Interested in learning more? Garland's article, Color, Transfer, and Application Parameters of Turfgrass Colorants, published in Agronomy Journal, will be freely available for the next 2 weeks. You can find a link to it in our show notes. Let's get back to the show. So let's maybe move on, because I could talk about this kind of stuff for like an hour. So you were also, as kind of a side tangent to your ratings, you were checking a couple of other things at the same time, one of which was color transfer and the other was viscosity. So can you tell me a little bit about what you were looking for those?
Yeah, so colorant transfer is basically, we were trying to quantify, following application of all of these turf colorants, we wanted to see how well each product adhered to the leaf blade. And, you may be asking yourself, well, why in the world would you be concerned with that? But if you think about it, whether it be a golf course, golf ball rolling around on a treated turf, you don't want your players to pick up a ball and have coloring all over it. And another important issue is on athletic fields. If you apply one of these products on a field that's going to have players on it with uniforms and they fall on the ground, that uniform will be stained pretty severely afterwards, and that can have its own set of issues. So, like I said, after application, we screen all 27 products for how much colorant actually came off of the plot. And how we did that, we have a small device that we made in-house that basically had a 10-pound weight that we attached a paper towel to, and we would literally drag that the length of each plot, and we would get varying amounts of colorant on that paper towel for all of our different products. So screening all 27, we picked kind of the worst of the worst. We picked the top 8 products that transferred the most product off of the treated turf, and we did a more extensive study to try to see how long it took for those products to resist transferring onto an absorbent cloth. And then viscosity testing, whenever we were mixing these products, it was very noticeable that there was a vast difference in how thick each product was. Some would be like water, and then you'd have some that were literally similar to like a house paint. So we wanted to try to quantify the differences in product viscosity for all of these.
Interesting. So then, what were some of the results that you found?
So from the overall product evaluation trial, we saw a number of different colors. As we mentioned earlier, for the many different products, we saw different colors such as blue, very light green or lime green colors, certain colors that we might think would be unnatural in a natural turfgrass setting. Then we had some products that were natural green color, and then we had some products that wouldn't provide much color at all. So we were able to group those in 3 different groups. Like I said, one group being kind of the unnatural color groups, second group being kind of our natural green color products, and then another group that just didn't provide much color change at all. And then within those different groups, we were able to rank those products, from best to worst within each of those groups. So, like I said, we identified products that may be not desirable for your high value turf areas, like a golf course where they produce a very light green color or a dark blue color. And then we were also able to find the products that would produce more of a natural green color. And then from our intensity ratings, we were able to kind of see how long these products lasted throughout the winter. Now, our unnatural products, or our unnatural color products that I was mentioning, one thing we found with those is those actually lasted longer than any other products. Whereas our more natural green color products, they would not last quite as long. On average, they would last probably about 4 to 5 weeks before they would start to go off color and would require a second application.
And what did you find for your color transfer and viscosity projects?
So for the transfer portion, like I said, we identified kind of the worst of the worst products in terms of colorant transfer. And for those products, what we found was typically for those that transferred more, you would need to plan for about a week and a half to 2 weeks until those would result in an acceptable level of colorant transfer. For our viscosity testing, we really had a wide range there. We really didn't group those in any particular order. It was kind of a natural progression, starting from 0 centistokes, which is a unit of viscosity, all the way up to about 250 centistokes. So again, water is right there at 0. So we had a number of products similar to water there in viscosity, and then we'd have some that were like we mentioned earlier, similar to house paint, that were much more viscous.
Once you had all your results, then you kind of were hoping to develop some resources for turfgrass managers to be able to make some decisions about what's best for them. Can you talk about those resources that were developed?
Last year, we put together an extension publication here at NC State, kind of summing up the many turf coloring projects that we've done over the last, 6-7 years now. And basically what we hope is that it provides a good resource for turfgrass managers to have, so they can see how these different products perform, in terms of color, how long they'll last, if they're looking for a specific product, on an athletic field, maybe that would be more desirable in terms of the product does not transfer quite as much. So after the conclusion of these different products, we have been able to sum it up to provide a resource for turfgrass managers so they can select the product that fits their situation the best.
Speaking of other papers, you've actually published 2 other ones recently with us. So do you want to talk about what those papers are about?
So with our first paper, we expanded on our colorant transfer testing. Like we mentioned earlier, we thought that we were getting higher levels of colorant transfer when we applied these products in cooler air temperatures. So we wanted to set out to try and improve that. So we selected a couple products and we applied them at 25 degrees Fahrenheit, 45 degrees Fahrenheit, and at 60 degrees Fahrenheit. And what we found was when we applied these at 25 degrees, we were getting 2 to 3 times more colorant transfer than when we applied them at 45 or 60 degrees. So that was very helpful, and can have major implications when you apply these, say, to an athletic field late in the year, December, early January, whatnot. And then our most recent paper, we've heard claims from superintendents they like to apply these during a frost or during a heavy dew. So we wanted to look at leaf wetness and during application to see if that had any effect on the visual aesthetics of that turf colorant application. So again, we took a couple different products and we applied them to both a dry and wet turf. All right. And what we found was a couple products really were not affected by the leaf wetness at application. But there was a couple that when there was moisture present during application, it really helped their visual appearance after application. So specifically, the products that were not affected were very low in viscosity. They were much like water, but the products that did benefit from that leaf wetness were much higher viscosity products. So when we applied those to a dry turf, we were seeing a bit more streaking, but when the moisture was present, it would help alleviate that streaking and it would coat the leaf blade more evenly, and we would get a better visual product at that point.
Fascinating. What fun questions. So then, obviously, there is yet more work to be done. So can you talk about some of the future research goals with this, whether that's your projects personally or just in the general field?
Yeah, so other than the work we've done here at NC State, there's been a few projects throughout the years, and a lot of the work is focused on product evaluations. And as we've gotten further along here, the products that are available now have improved greatly, even since 2011, 2012, when I started this work. So I think kind of the next step is building upon kind of what we've done with our last two papers and looking at the different environmental conditions or different application techniques to try to enhance the appearance of that turf colorant following application. You know, what can we do? Can we apply it a certain way to improve the visual color? Is there a certain weather condition that these need to be applied in or whatnot?
Yeah, that's super neat. I'm excited for you to continue on. And then I've got 3 questions left for you. First question is, if people want to learn more about these topics, where can they go for more information?
So yeah, if people would like more information, I would encourage them to visit our Turf Files website, which is turffiles, all one word, .ncsu.edu. There you'll be able to reference the extension publication that we published last year that has a good summary of all of the various turf colorant projects that we have done over the past 7-8 years.
Awesome. We will include a link to that in the show notes, as well as to those other 2 papers that you mentioned. Second question is, if people want to get involved or help with this, what can they do to jump in?
One thing I'm always interested to hear about, for turfgrass managers or whatnot, is exactly how are you using these products? You know, you can use these in so many different ways, how you're applying these, whatnot. So if I could, suggest anything to anyone is, if you use these products, be creative, think outside the box, and, if you come up with something that seems to help in terms of the colorant application, please, reach out. I'd most definitely be curious to hear about it.
Last question for you is, what is one fun fact that people would not know about you if all they had was your research?
Ooh, one fun fact. Man. Something most people would not know about me just off research. Well, I am a pretty avid outdoorsman. I enjoy being outdoors. Specifically, I enjoy hunting and fishing. So, yeah, that's about as interesting as I get outside of research.
Everyone's got hobbies. That sounds really fun. I mean, I'm not a hunter, but I do enjoy fishing.
Hey, it's getting about fishing time here in North Carolina, too, so I'm starting to get the itch to do a little fishing now.
Nice. What a pleasure to have you on the show. Thank you so much for sharing your knowledge and your research and for putting so much of your life's work into things that I imagine touches almost everybody at some point that enjoys recreation.
Well, that's the goal.
Wonderful. Well, thanks for being on the show.
All right. Thank you.
Thank you for listening to Field Lab Earth. You'll find a link to today's paper and other resources for this episode in our show notes or on our website. If you have any questions, comments, or recommendations for show topics, please contact us at podcast@sciencesocieties.org or on Twitter @FieldLabEarth. If you'd like to hear more content like this, please subscribe, and don't forget to rate and review us on iTunes or anywhere else you find your podcast if you like our show. This podcast is a joint production of the Tri-Societies, the American Society of Agronomy, Crop Science Society of America, and Soil Science Society of America. Special thanks to Lobo Loco for the use of their song Spook Castle on the intro and outro of our show. Opinions and conclusions expressed by authors are their own and are not considered as those of the American Society of Agronomy, Crop Science Society of America, Soil Science Society of America, its staff, its members, or its advertisers.